Subh khair everybody. So last time I was talking about the slope lines, and I would just like to finish that topic with this topic, phase diagram. All of this, you will benefit from it when you kind of dig deep into the dynamical systems. But this is just all right. Thank you. Experience helps. So phase diagrams. So let's say I have this equation. Any initial impression about this equation? What kind of an equation is it? Of course, it's first order, but what else?
Non-linear.
Non-linear, because the dependent variable has power 2. Okay. So if you just look at this equation, so you can find that p is equal to 0 and p is equal to 1 are the two solutions of this particular equation. Okay, right? But since there is a time derivative here, so it's kind of an evolution equation as well. So these are the 2 points where p becomes constant, or dp over dt is 0, right? In phase diagrams, we generally talk about these points and we call them equilibrium points, okay? Because when something is not changing, that is something that we associate with equilibrium. So if I draw a phase diagram, so I will draw a point p is equal to 0 here and a point p is equal to 1 here, okay? In phase diagrams, this is a line. You can also do the same stuff in terms of p as a function of t, and you can write p is equal to 0 and p is equal to 1, and then you can draw these lines. And of course, looking at this equation, you can again apply the slope field concept. And if you do that, so what you will find is that the behavior is something like this, and over here is something probably like this. But that is for the slope field. I leave it to you as an assignment. But if I do the what we call the phase line concept, that is more instructive. Then these are my equilibrium points. Now tell me, what will be the value of dp over dt for p less than 0? P less than 0, what do you think the slope would be? So I'm just asking for the signs of it. Negative, yeah, very good. dp over dt less than 0. Convince yourself that this is dp over dt. Well, it is also showing here, and over here it is also dp over dt less than 0. Okay. So on a phase line, what you say is that if it is less than 0, so it is coming towards this. If it is greater than 0, then it is going towards this. And if it is less than 0, it is going in again in this direction. All right? Okay? So if you just look at this point, by the way, these are both are equilibrium points. So if I just focus on this particular point, then this thing is going inside and this thing is going away from it. Yeah? So something is going towards it, the other thing is going away from it. So this kind of equilibrium point is kind of a semi-stable point because it is going towards one, going away from the other. Now if you look at this particular point, it is going towards it, it is going towards it, it's a stable equilibrium point. It's not symmetry, it's the way the slopes are aligned, that both points are going towards this point. So this is what we call the stability. There could be another point, could be in other case, where this thing will be going in this direction and this thing will be going in this direction. In that case, we will call it an unstable point. In this particular case, one thing is going in this direction, the other is going away. So this is a semi-stable point. Okay? So this thing we call as the attractor, and this thing we call as a repeller. So the real repeller is this one, actually. The unstable point is the real repeller. The semi-stable point, you see, it deals with both, because it is going towards it and it's going away from it, so it's a semi-stable point. So this is the nomenclature, and that is how you also classify the system. So this is all qualitative analysis. You look at the differential equation and you find out the equilibrium points just by simply looking at them. So you don't need to solve anything, and that's the whole point of this analysis. So it's all we call qualitative analysis. So what if, so I don't know any of you, maybe, have you seen an equation like this? Can you identify this equation? It's a nonlinear equation, but a population growth rate is a very well-known equation. Logistic map equation, have you heard of it? Anyhow, okay, so let's say I add a minus h here, and this h is some control parameter that I have. So this is something that I can, fiddle with. And now you, let's say, solve this equation for h is equal to 1. Now do it yourself and tell me what you get. And then I will tell you what is the conclusion that I can draw from it. So in an equation where I had two equilibrium points, I have introduced another term which I call the control parameter, and now I see what happens. And this is very instructive. We can draw very significant conclusions from it. So age could be anything. It could be you have got rats and age is the poison that you give to them. It could be something that helps to breed them, more. So anything. So for age is equal to 1, of course, right? If it is like a free parameter, then of course you can't solve. But age is equal to 1 here. And remember that p is equal to 0 and p is equal to 1 are the equilibrium points. Yeah, so you put it equal to 0 and you find out what it is. You just have to solve the equation. P into 1 minus p minus 1 is equal to 0.
So two different equilibrium points?
That is it. The only thing that you find from here is that the equilibrium point is different now. So it means with this control parameter, the system changes its equilibrium points. And if I keep changing this parameter h, there comes a time when you will have no equilibrium point at all. So this is all changing. So that is what we call in dynamical systems a bifurcation diagram, or a bifurcation thing, where a control parameter shifts the equilibrium points. So these are all features of a dynamical system, which are very important. So I'm just giving you a very basic idea of this. So now I switch to the differential equations in more quantitative manner and the methods. But before that, there was something that I didn't talk about, and you might get a thing or two from there, and that is the degree and the order of the differential equation. Okay? Questions, please ask. Yeah.
Sir, for P P less than 0, I don't understand how the arrow is pointing upwards.
P?
For P less than 0, on the
लेस देन जीरो है ना, तो लेस देन जीरो की तरह यहाँ पे इधर भी तो ऐसे ही है. It is going towards it. Greater में it is going away from it. It's grows ना. So less पे it is going towards that. This is just the nomenclature that you adopt.
So for between P0 to P1.
Yeah, it is increasing. So it is going away. You see? It is going away from this point. So 0 to 1, these are the two equilibrium points, and you need to see that what is the nature of these equilibrium points. So one is the semi-stable, the other is the stable equilibrium, and I gave you an example. There could be another example where both are going away from it, and that is the example of an unstable equilibrium point. So it can go in many directions. You can talk about, a characteristic equation, and you'll write down the the eigenvalues. They can be real, imaginary, and they correspond to centers and homoclinic orbits. So there's a whole dynamical system theory, but I'm not going to go into that. Please go.
Sir, why do we care if this point is like an equilibrium point? What does that help us do?
It helps you to identify these are the points around which you can look at the behavior of the system.
Okay.
So these are the good reference points to qualitatively assess the behavior of a system.
Okay, so like to understand better, I think पिछले lecture में you actually explained कि like in this your logistic regression की equation है, there's three curves ना, एक तो ऊपर वाली है, एक ये बीच वाली है, and then नीचे वाली है.
I didn't talk about this equation last time. This is the first time I have talked about this equation.
You explained last session कि when we solve this ODE, तो हमारी जो particular like solution होगी उसके लिए we have three domains जो हम choose कर सकते हैं.
Yeah, so that was one specific example.
Yes.
That there was a differential equation whose solution was y is equal to 1 over x square plus c, and corresponding to the initial value, I think this was y0 is equal to -1 if my memory serves me right, and I got this point, and then I plotted these three regions, and I said that in terms of the solution of the differential equation, these are the three regimes where I can talk about the solution, but looking at this initial value, I am confined in this particular region because my curve must pass x is equal to 0 and y is equal to -1. So, but that is in a very different context. This is a very different context. Here we are talking about a dynamical system that was just dy by dx, which was just y as a function of x. But over here we are talking about a dynamical system because over here something is changing with respect to time and not with respect to space, right? So there are two ways that things change in the world around us, either with respect to space or with respect to time. Well, there's another thing, but I can't get into that because there are certain things which also change in velocity space, but that is phase space, not this kind of space that we talk about. Generally speaking, if you look at anything, Newton's second law tells you everything, that everything changes either with respect to space or with respect to time. So although your physical quantities are defined that way. Okay. So now,
Sir, can you give us an example by how external parameters can change the stable points of a system? In a
बताया अभी आप h की value 1 आप लें, तो your p changes. It's no longer 0 and 1.
No, but like in a physical phenomena, for example, if we talk about the
You think this is not a physical phenomenon? Logistic map equation is a physical phenomenon. So I'm not talking something from Mars. This is very physical.
okay.
Okay. Physical hai ye. This is not abstract.
Yeah, but actually I couldn't understand it. Like, for example, if you talk about the optimum temperature of a system, so then how can external parameters actually change the stable point?
So okay, good. So let's say this is population growth. So the population increases, you will have less food. So initially by eating something, they will flourish, and when they will have nothing to eat, the population will begin to dwindle. And then again, there comes a time when the population becomes very thin, they have enough food, they will begin to grow again. So this is kind of an oscillatory behavior. So I can't go into the depth of all this, but the point is chaos also emerges from here. But anyway, the point is that this is what it is. That you talk about a physical system, and control parameter means different things in different settings. In this particular case, if you take it as a population growth, this is essentially what it implies.
So stable points can be variable, or
that is the whole idea. That what you call a stable point, equilibrium point, not the stable point, the equilibrium point, that begins to shift as you change the control parameter.
Okay. And are there some scenarios where the equilibrium point remains constant no matter what we do?
No, but in terms of control parameter, that is not possible. But yes, if you do not add anything like this, then these are fixed points. Yeah.
I have something in my mind. For example, if you talk about the atomic structure, we do have some stable points where the electron remain, stable. So can we change that, or like, is it the true equilibrium or stability points?
Yeah, that is what I was going to say actually, because you need to tell me the equation, because I am talking about an equation, a particular structure, and I'm drawing certain inferences from there.
Right.
So you need to tell me what kind of an equation is it, and whatever the scenario in your mind ought to be, described by an equation. Okay. Because that is what we have learned, that the universe around us is governed by certain equations. So we ought to have that equation before us, and then we can say something about it.
Okay, I can be
wrong.
I
might not be able to say anything about it because that equation might be, very intractable.
Right. Okay, thank you.
Don't hesitate to ask. So, meaningful, meaningless, not so good, good. These are all very good questions in my view, because they make us think. And sometimes certain questions, they may be very harmless, but they have never crossed my mind, and that's the whole idea of discussing things. So this is a discussion, not really, I'm not giving you any, lessons as an instructor. This is just sharing of knowledge. अहमद साहब आप आ गए, अच्छी बात है. मैं सोच रहा था कि आपसे मुखातिब होके सवाल करूँगा. So I'm going to do that. So I'm going to talk about basic stuff that I didn't get to talk about. So before I, talk about the other things, about the order and degree of the differential equation. I'll give you 5. So here we go. Number 1. So first things first, order is like dy by dx. That is the order, first order. d2y over dx square, that's the second order. And when I say degree, so first let me write down something and tell you what it is. So how do we do that? First, let me explain, and then I'll give you a couple of problems. So the highest order is the highest order term, and as you can see, this is the third order, okay? And the degree is determined by the degree of the highest order term. So which one is the highest order term over here? This one. And what is the power over here? 2. So this is order 3, degree 2. Now, tell me what would be the case here. Ahmed, this question is for you first. Then I will ask anybody else. Go ahead. फिर मैं आऊँगा. निशात की तरफ.
Sir, I think order 2 degree 1.
Order 2, degree 1. How many of you concur with the answer that well, that's a good idea. Okay, so order is 2, that is something, and now the degree. तो आंसर आपको लगता है ये डिग्री 1 होनी चाहिए, राइट? But there is something fundamentally not wrong but different from what has been given over here. And what is that?
Sir, highest degree, highest order की जो degree होती है, like जो power होती है, उसको हम degree बोलेंगे.
तो वो तो यहाँ पे हाईएस्ट ऑर्डर 2 है और उसकी डिग्री 1 है, तो मैटर इज रिजॉल्व.
Sir, लेकिन अगर हम cos dy by dx की expansion करेंगे,
So this nomenclature holds true if and only if the equation is written as a polynomial. Because it is derived, the analogy has been drawn from the polynomial. If it is not written as a polynomial, then of course this doesn't hold true, so cannot be determined. Yeah.
Sir, why how much can it
So let me write down an equation. So this is an algebraic equation. Now tell me what you can say about this. Can you say anything about it? Is it a polynomial? No? Yeah. So that's the thing, that all of this has been drawn from the, the way polynomials are defined. So let me give you another example. That's another interesting example. Okay, go ahead. Ji.
I have a question about the cosine. So you said we can't determine the degree because of the cosine, but similarly, can't you also not determine the order because if you expand it to the dy by dx?
ऑर्डर तो है ना, ऑर्डर तो है हाईएस्ट डिग्री डिफरेंशियल विच इज अपीयरिंग द फर्स्ट ऑर्डर ना यार, उसका तो इशू नहीं है ना. हाँ, तो कन्वर्जन जो है वो आपको जो मर्जी कर लें आप, dy by dx की पावर 1000 भी लिख लें, लेकिन हाईएस्ट ऑर्डर तो d2y over dx स्क्वायर है ना. दैट इज नॉट अ प्रॉब्लम, इट्स द डिटर्मिनेशन ऑफ द डिग्री विच इज अ प्रॉब्लम.
highest order की power होती है, वो degree होती है.
Only when everything is written as a clean polynomial type thing. If it is not, like cosine of something, log of something, then you can't. Because of course, as you rightly pointed out, you have to expand it. And it's no longer a polynomial because, okay, it goes till infinity. Polynomial is finite number of terms, right? Okay, just tell me about this. Once again, Ahmed. Ahmed is the yardstick. Yeah. Go ahead, Ahmed. Can we, first of all, tell me again, looking at this one, what is the obstacle in my way? The obstacle in my way is this power. So I want to get rid of this power in order to come up with something substantial. Excellent. Yeah, this is what we do. So once I do that, in this case, I can deal with this. So now it's perfect. I have order 2, degree 3. So let's try and do another one, which looks like a very difficult thing, but in principle it is not. Y is equal to x dy by dx plus under root 1 plus dy over dx whole square. Go ahead. And that's the last one. The rest I leave it to you, Go ahead. Very good. Excellent. Excellent. Yeah, perfect. ऑफ कोर्स dy by dx है तो ऑर्डर तो वो बन ही रहेगा. कुछ करना पड़ेगा. ये जो आप बैठे रहते हैं मैथ्स में, यू हैव टू डू समथिंग, यू नो. उधर ले जाएं, उधर नहीं, करके दिखाओ मुझे कैसे करना है. टेल मी, उधर ले जाएं, उधर नहीं. या हाँ, ऑफ कोर्स यू डोंट हैव टू आंसर दिस वन. So do something. I'll. So you take this one to this side. Take the square of it so that you get rid of that under root. Yes, of course, because you will get rid of this thing, so you will have order 1 and degree 2. That is it. ठीक है? Make sense? जी. No, यही तो सारा मसला है. असल सारा इशू ये है. पावर का भी इशू है और पॉलिनोमियल टाइप होना चाहिए. तो पॉलिनोमियल क्या है? दिस इज योर पॉलिनोमियल. मतलब इसको इन्फिनिटी मत करें, कोई फाइनाइट नंबर रख लें, तो आपके पास ये सब चीज़ें जो हैं ये पावर्स में नहीं है, आपके पास होल नंबर्स हैं. 0 1 2 3 4 5. नो 5 by thirds, 1 by thirds, 3 by fourths. जी एन नहीं होना चाहिए, फाइनाइट नंबर ऑफ टर्म्स होनी चाहिए टू कॉल इट अ पॉलिनोमियल. Oh, and power n, sorry, I'm sorry. Thank you for the correction. You are up and running, all awake. Yeah, so yeah, x raised to power n. Good. चलिए जी. Yeah.
Why do we want to get rid of the fractional power of the derivative? अगर हम एक vague sense में बात करें,
वेग सेंस नहीं है यहाँ पे. बात ये कि all of this, the analogy is drawn from the polynomials. So everything should conform to the stuff that we have learned about the polynomials. So this is all with respect to something. So when you talk about this is the whole idea that I wanted to give you, okay? Order and degree, you just simply can't do like this. Otherwise, in this particular equation, it appears that it is very obvious that the degree is 2, order is 2. Oh, sorry, degree is 1 and order is 2. But that is not the case because something over here is not determined. And similarly here, there was no such problem like this, but there was this power and I wanted to get rid of it and I wanted to get something which is 3 or 2 or 1 or 4 or 5. Right? Polynomials की तरह ही dy by dx की degree and तो polynomial क्या कहते हैं? How do you determine? Fundamental theorem of algebra tells you nth order polynomial n roots, right? Or this is how you write down a polynomial. Do you write like this? No, this is not a polynomial, right? So similarly, when you talk about the degree and the order and particularly the degree, you have to conform to this particular thing which is for the regular polynomial. Okay. So now we go on to solve quantitatively the differential equations. So the first things first is the separable equation. And either this or you can write, or it can be equal to another form, let's say. Now I have a question. If you write What do you think now? Is it a separable equation? Okay. So the separable equation can either be in a ratio or as a product you can write. Otherwise, and the reason, y is on one side, x is on one side, everything becomes integrable and you can integrate. Okay. So I can write q of y, d of y, p of x, d of x, and I will have some h of y, some, let's say, r of x plus some constant. And that is how you solve it. Okay? This is the first thing, separable equation. This is the easiest that you get. Just one thing for Ahmed. So if I am given this thing and I write like this and I integrate, what would be the answer? इतनी इंटीग्रेशन आती है आपको? Okay, so this is log of y is equal to log of x. Okay, and then
You could go coordinates.
plus the integration constant, right?
Yes.
But whatever the form of the integration constant, it is not going to have any effect on the eventual
Yes, so that's all. Yes.
things because it's a constant, and when I take the derivative with respect to x, it is going to give me 0. So that gives me immense leverage to choose a constant, the form of the constant that facilitates me. So over here, there is no problem, you know, I can write like this as well. But then I can't use the property that of log, you know. So it's better that I write this as log of c, and immediately my answer would be y is equal to cx. Because e raised to power c is again a constant, something like that. But you see, the thing is, if I choose it to be log, I create some kind of facilitation for myself. And it will have no effect on the eventual things because the derivative with respect to x is 0. So this is a very important thing, and this gives me immense leverage that I can choose a constant of my liking so that I can simplify my calculations. This is one point that I wanted to make. All right.
That's a small comment.
Yeah.
It's always best to guess a solution for a differential equation.
Yes.
And here you can immediately guess y is equal to a constant times x. Just put it in and
Yeah.
you get 1 is equal to 1.
Yeah.
So it's always best to do that. Next step is integration or whatever other techniques.
True. So, Abhi, let's, another thing I'm going to tell you that we sometimes don't realize that we are doing something marvelous, but look at this equation. So as Parvez Saab said, over here, it is very easy to say, looking at this equation, that y is equal to 2 and minus 2 are the two solutions of this differential equation. This is what in mathematical parlance we say that, but just by simple inspection of the differential equation, you can, just like in dp over dt is equal to p into 1 minus p, just by inspection, I anticipated that there are two solutions. Please, Ahmed, yeah.
Sir, like another comment, जो आपने फॉर्म लिखी थी dy by dx is equal to p of x plus times q of y, है ना? So wouldn't the roots of q of y also be solutions? जो अगर
रूट्स की बात नहीं हो रही है, सॉल्विंग दिस डिफरेंशियल इक्वेशन की बात हो रही है.
yes sir, you're talking about solutions वाला ना?
No, but the point is that if something is written like this, the separable equation doesn't hold because you cannot, the whole idea of a separable equation is y is on the one side, x is on the other side. In this form or in this form, you simply can't do that.
That I'm talking about when there's a product.
Mm-hmm.
The roots of the polynomial phi of y, या जो भी function phi of y, those will be solutions.
Yes, as you can see here, y is equal to 2 and minus 2 are the two solutions. That is essentially what I'm talking about. But look at the way we do it. What we are going to do is this very simple. But tell me what is very special about this without even noticing that we have managed to solve this.
I guess it tells us the points where there is no change.
No. There is something non-trivial about this equation, but somehow we have managed to solve it in a jiffy just because it was in the separable form. But there is something that you should immediately appreciate. No, that's okay. It's a non-linear first order differential equation. But you didn't even consider. Most of the time we just do it without realizing that this equation was given in such a manner that I could just do it as a separable equation and solve it. Right? That's amazing, isn't it? But then there is something else which tells me that it will show its true color somewhere. So let me write that and tell you how it shows its color. Okay, all right. So without going into the nitty-gritty of anything, once I solve it, this is the solution that I get. This is the solution of this differential equation. Okay? This is a first order differential equation, one parameter, C is the one parameter, and now what is it that you call a general solution? A general solution is the one from where all the solutions can be obtained. So by simple inspection over here, you said that 2 and minus 2 are the two solutions of this differential equation, right? So now tell me, for which particular choice of C will you get 2? Excellent. Now tell me for which particular choice of C you will get minus 2. You simply can't get it. And that is where the nonlinear differential equation shows its color. You can't obtain minus 2 from this general solution. So a solution which cannot be obtained from the general solution is called what? Singular solution. Excellent. So y is equal to minus 2 is the singular solution. And you note this thing down, that only a nonlinear equation can give you these singular points. No linear equation shows this behavior. This is very, very nonlinear centric behavior. So if you have a nonlinear differential equation, PDEs, it's very well known, and I'm not going to talk about the PDEs, but this is a nonlinear ODE, and immediately you see there is a singular point. Okay? Questions? Please ask. So I am just going to talk about the stuff that generally it's not talked about and which is very fascinating, at least to me. Yeah, Ahmed?
How do we know we're getting a singular solution?
We do not know. A priori, you don't know. Yeah. So you write down the general solution. When you write down the general solution, by the very definition, a general solution is one from which all kinds of particular solutions can be obtained. Here by inspection, you saw two solutions, 2 and minus 2. One you can obtain, the other you can't obtain. right? And that is a singular solution because it's a nonlinear equation. Yeah.
सर सिंगल सोल्यूशन क्या है कि उसका मतलब कि फाइनल अगर पॉइंट क्या होता है कि मतलब कि हम डिफाइन करें कि सिंगल सोल्यूशन है तो फिर
So singular solution by its very definition is the one which you cannot, so in the process of solving this differential equation, you lose an solution. This is what we call also, so if you, any good book, so it will say losing a solution. So losing a solution means you have a singular solution. This is how you have lost a solution. Okay? Yeah, please Ahmed, go ahead. We have, if I put c is equal to 0, I obtain 2. So the whole idea is, from the general solution, I should be able to retrieve all the possible solutions. That is why it is called the general solution. But y is equal to minus 2 is not obtained here.
Yes. So
Right.
that's my question. Why do we obtain 1 but not the other?
Because it's nonlinear. And that is the peculiar property of a nonlinear differential equation, that in the process of solving a differential equation, you lose one solution. Yeah.
So you always lose 1, not both.
Oh, of course. सब कुछ ही lose कर देंगे तो फिर what are we getting, you know? Yeah.
Is it like
Uh-huh.
is it like they are guaranteed that you will lose 1?
Well, you can, you may not. But I'm giving you an example where you lose a solution. Yeah. Well, most of the times you will. And I am going to show you more about it, and I have talked about it because when I'm going to solve the higher degree equations for you, this is something that you will encounter every time. This is a property of a nonlinear equation. And I'm going to talk about just the, ordinary differential equations. PDEs can have infinite singular points actually.
So is it because while solving this equation, we are converting the non-linear into the linear part? So
Not really. आप क्या कर रही हैं? आप यहाँ पे वही कर रही हैं जो आप करती हैं. You will write it down as y minus 2, y plus 2. You will write it as a over y minus 2 plus b over y plus 2. You do the partial fractions, you find out the value of a and b and you plug it in and you solve the equation.
non-linear का वो y minus 2 और y plus 2 दो इसके फैक्टर बनाएंगे. इस वजह से
So factorizing is a problem, yeah. So factorizing में ये हो गया, लेकिन well, in the non-linear case yes, but in the linear case no. So आपकी बात ठीक है. I have lost the solution somehow if I look at the method. So in doing so, I have lost the solution. That is a good observation, yeah. So all that I can say over here is, but I have not linearized it. It is still, that's the way the partial fractions are done, right? I have not invented anything new here.
सर तो अगर हम इसको ग्राफ करेंगे तो y इक्वल माइनस 2 पे क्या बिहेवियर शो करेगा? नॉर्मल वहाँ पे इक्विलिब्रियम पॉइंट होगा,
Of course.
लेकिन हम उसको सोल्यूशन
But you have lost the solution, yeah, because it cannot be obtained from a general solution, so you have lost the solution, it's a singular solution. So this is nomenclature. How do we define certain things, right? अभी अहमद चलें थोड़ा सा आगे. बोलो आप. I'm happy to answer questions, but the only thing is that how much I will be able to cover. So the idea is to have a good discussion. So let's not try and get to anywhere. Yeah. Okay.
So when we're like integrating वो जो है separable equations थे, won't we get like some terms जो ln वगैरह में है? We will ना.
Yes.
So ln की जो domain है, that is the positive numbers वगैरह कि उसकी कोई relation है कि y can be minus 2. कैसे?
Well, yeah, that's another thing.
कि like domain will affect what values we can.
Very good. Yeah. So this is again one of the reasons. So what he's trying to say is कि log of y minus 2 और log of y plus 2 आपने लिखा है, तो आमतौर पर x greater than 0 पे you define things not for less than 0. Log is not defined over there, right? तो अगर आप if you look at the whole function, so what happens on the other side? So yeah, very right. ये just look at the gamma function. पता नहीं आपने gamma function का कभी plot देखा है या नहीं? So gamma function is a very smooth function. It is also related to known functions, gamma function, but it has a very smooth function in behavior for x greater than 0. But if you look at less than 0, there are poles and the range where it behaves and then it misbehaves, and so it has to do with that as well. So aamtaur when you dig deep, it has to do with the functions also and the way they behave. That's a very good observation again. Well done. Yeah. So these are the possibilities of getting, but not always you will come up with this kind of an explanation. I'll show you why I'm saying that. But yeah, so when you say that in the process of solving this, you have lost a solution, basically you are indicating that in your method somewhere you have lost it. But this you will only encounter for a nonlinear equation, not for a linear equation. वैसे आप अगर मैं if I write dy by dx is equal to let's say 1 over x, okay? So I have y is equal to log of x. So the same problem happens over there as well, right? Still you can't go to anything, you can't even say 0, right? That is why you write down the modulus here. So the behavior stays the same over here as well. It's a linear problem, right? So it has to do with the behavior of the function. So not necessarily this is the reason, because there are many cases where you will have this log behavior and you can't say that now there is no singular solution here. Okay. So these are good educated guesses, but this is the property that a nonlinear equation exhibits, that you will get a singular solution. One of the solutions of the differential equation. I will not say, देखो ना यहाँ पे equilibrium point मैंने आपको कहा है, equilibrium point deals with a dynamical system. This is dy by dx. It is by no means a dynamical system. So you will call it a solution, not an equilibrium, right? Equilibrium जो है वो time फिर ऐसा कहेगा कि मुझे आप जो है वो nomenclature के ऊपर बहुत ज़्यादा जोर देते हैं. So I'm an old school, I would rather stick to the okay, so this is done, and now just one thing, purely for the reason that I have this very peculiar situation where I will be given something which will be in more than, well, before that I have to do one more thing. So the next is the linear equation. So first order equation would be this. Standard form of the differential equation is when you, with the leading differential, there should be coefficient 1. So I will divide throughout. So immediately you have to say that this should not be equal to 0, and I write this as d over dx plus p of x y is equal to f of x. This is my linear equation. This is first order non-homogeneous equation. Okay. So as Prabesa pointed out, we assume, we force the stuff. So over here we will say that this is a linear equation and a non-homogeneous one, so I assume that this is the solution of this differential equation. So if this is the solution of the differential equation, what does that mean? That if I plug this solution in here, left hand side will be equal to? Go ahead and prove it. Yeah, this is not for you. So I can write अब साबित करें कि ये solution है. YC is the solution of which particular part? So this is what we call as the complementary solution. So complementary solution means I'm saying that this is the solution of this part. And YP means this is the solution of the non-homogeneous part, right? So if I say that YC is the solution of the homogeneous part, what does that mean? That dyc over dx plus p of x, yc is equal to 0. So this becomes 0. And now you have dyp of p, and this is the solution of what? The non-homogeneous part. So f of x is equal to f of x, and hence proved. Isn't it lovely? तो एक साहब हैं हमारे बड़े दिग्गज प्रोफेसर हैं, उनसे सवाल किया गया कि मैथ्स जो है उसमें ये कैसे आ गई कोई चीज़, तो वो कहते हैं मैथ्स की कोई लॉजिक नहीं होती. सो आई वाज काइंड ऑफ स्टन कि फिलॉसफी में लॉजिक होता था, जो लॉजिक के अंदर मैथ्स पढ़ाई जाती थी. तो आई मीन यू कांट टॉक अबाउट, I mean, you can't say that mathematics is developed without logic. So we say this is the solution of this, and then this is the solution of that. And of course, you have to prove that my assumption is correct. When we say that, maybe sometimes people are, confused in the sense that they can't appreciate beforehand how somebody said that this could fit the bill. Yeah. So in many mathematical equations there is trial and error, but once you look at the structure of the equation, with experience you tend to come up with better educated guesses than others, because you play with the equations. So sir, for instance, anybody who knows, let's say, let me write this thing. So for the first time, let's say you have been given to solve this equation. You may not anticipate it, but with time you will immediately say that this will show an exponentially growing behavior because the derivative and the function show a linear behavior, right? So now for somebody it may be, sorcery or whatever, but if you look at the equation and you are familiar with this thing and many times you have done it, so immediately you will say that it will show exponential behavior. So this is what comes from experience. Maybe for the first time you will be too caught up doing the integration that you don't see this relation. But if you do it 4 or 5 times, and maybe one of the fine mornings you will just appreciate the fact that if a derivative is written first order and the other thing is in the form of the same thing, not v square or v cube, you will have an exponential behavior. And that's what we call the linear behavior. This is a linear relationship, right? So this is just a passing comment. What we say is a brief digression. just to tell you about the efficacy of mathematics. All right, this much is clear? Good. So, now that you have learned the separable equations, so what would be the answer? If I write down this, YC will look like what? Well, you have to write down Y of C. Yeah. So the answer would be all right. Make sense? So my assumption now is that if I have to find out the particular solution, it would also look like the complementary part. But what is it that I need to change here now? Huh? Yeah, and why should I do that? Because if I write down C, then there is no way that I construct a new solution. So if I want to construct a linearly independent solution, then I should say that my YP would be U of X, Y of 1 or Y of C, whatever, you can call it Y1, right? And now you plug that in this particular equation, which is dy by dx plus P of xy is equal to f of x. Once you multiply it with some variable coefficient, then it means it will also give you a linearly independent solution. But this thing is now a variable, and that is why this method is called variation of parameter method. Okay? This is the variation of parameter method to find the solution of the first order non-homogeneous differential equation. Yeah, it is the solution of the homogeneous part. जी अभी तो जिगर दिखाया करके ये दिखाऊं dy c by yc is equal to minus px dx. This will be log of yc is equal to minus integral px dx, and yc will be equal to, well, if you write down with the constant c times e raised to power, टूट बड़ी जल्दी जाते हैं, minus px dx. सॉरी अहमद, मैंने आपके लिए मुझे ये करना चाहिए. ओके, समझ आ गई ये बात? If you don't, then it will not be a new solution. Because your solution, there are two parts. One is the complementary part, which is the solution of the homogeneous part, and this is the solution corresponding to this. So this is, you can, at the moment you can call it an input. Okay? This is some way given to you to fiddle with the system. So now, this is kind of the natural response of the system, and this is the result of the consequence of your fiddling with the system. Okay? So yp, I assume, will also be like y1, but somehow I have to differentiate between the two because it involves x. So I multiply it with some unknown parameter that is to be found, and that is why this method is called the variation of parameters method. अब issue ये है कि majority of the people here, they have gone through this in one way or the other. For you, this is all very new. So in the process of doing things, I'll skip certain steps and I'll be very happy to help you, but I'm afraid I won't be able to do everything because I told you that I've been asked to do something that I do in 32 lectures. So of course in 8 lectures I can't do all of that. And also the majority of the people here, they are in 6th or 7th semester of their BS, or they have done their BS, so they are all, so this is like looking at the things again but with a slightly different perspective, or maybe the holes here and there, they are addressed, nothing else. For you it's all very new. So ये O levels के मामले में ये थोड़ा सा हमारे पास एक disadvantage है. So you can take it as a barrage of information coming your way. You try and imbibe. Whatever you don't, no worries. You will have a chance to do that later.
So why are we necessarily multiplying by a function of x? Why not a function of y? How do we know? Okay,
This is dy by dx. So this comes directly from the fact that y has to be a function of x, right? And the input is f of x.
Because the non-homogeneous part is a function of x, that's why.
Yeah, it's a function of x. No? It's all there because in the construct of the equation you have this thing. Okay, x है ना, function of y तो नहीं हो सकता. Function of y हो गया तो फिर तो मामला और हो गया. You have to write everything as y as a function of x. This is the whole idea of this, finding this differential equation, because the dependent variable is y and independent variable is x. Okay, makes sense? Even if it makes little sense, it's okay. Yeah.
जब भी हमारे पास नॉन होमोजीनियस होगी इक्वेशन तो वो हमेशा वेरिएशन पैरामीटर्स के थ्रू हम मेनली सॉल्व करेंगे.
Not necessarily. ये first order की बात हो रही है. If you have second order non-homogeneous, then you will have method of undetermined coefficients. You will have method of variation of parameters, right? So yeah, so this is only for the first. आप किस semester में?
हमारी मैथ फिजिक्स क्लास प्रोफेसर वाज नॉट रेडी.
अच्छा, ये बहुत ही हालात जो हैं वो कहाँ से किया आपने? बाहर से की है. वाओ, सो परवेज साहब, द मिथ इज ब्रोकन कि बाहर से तालीम जो हासिल होगी, यानी ब्लैक होल से बाहर नहीं, मतलब पाकिस्तान से बाहर. कहाँ, कौन सा मुल्क का नाम तो ले, मतलब here you go. Is it an exact type degree? I don't know. Florida State? Wow. परवेज साहब, इनसे तो आप डॉलर्स में फीस लें, मतलब थोड़े से, मतलब ये तो बात नहीं है. कुछ तो डॉलर्स आए हमारे पास.
लेकिन जो आपका बेस्ट वे होता है नॉन होमोजेनियस डिफरेंशियल इक्वेशन को सॉल्व करने में, वो तो वेरिएशन ऑफ पैरामीटर जो जनरलाइज्ड है. लाइक जो मेथड ऑफ अनडिटरमिन्ड कोएफिशिएंट है वो तो सम स्पेसिफिक फॉर्म्स के लिए हम अप्लाई कर सकते हैं. तो इन जनरल
Variation of parameters for any form.
हाँ,
Variation of parameters is general, no matter. But the only thing over there is that you need to know the solution of the associated homogeneous part, otherwise you will not be able to solve. Yeah, that's the only caveat. Otherwise, there is no restriction on the inputs. Method of undetermined coefficients, as you know, it has many problems because you can't choose an input which does not reproduce itself.
so it means कि it's a generalized method for first order set.
Huh. Okay. So then go ahead and do it, because we will have to do it again. So maybe I'm going to just leave it here, and I'll do it in detail once we talk about the second order differential equation and we use the method of variation of parameters over there. But this is the fundamental thing that I have discussed. Now let's talk about something which is very unique over here. That's called the exact equation. Okay. All right. So it begins with the fact that z is a function of two variables. So I told you at this beginning that we are going to deal everything over here which is a function of one variable, and here we are going to encounter something which is a function of two variables. Okay? But all is not lost, but of course there will be a difference over here that will be reflected, and we have something to learn over there as well. So let's say this is equal to some c. Okay? So if you take the exact differential, what would it be? dz will be equal to and if it is equal to c, then of course it is equal to 0, right? And the exact equation looks like this. Okay? So it means m is equal to curly f over curly x and n is equal to curly f over curly y. So the criteria for an equation to be exact is that, oh, you said just white, that curly m over curly y should be equal to curly n over curly x, right? And now if you look at this, this is what it is. So this is what we call the integrability condition also, right? एसएम मैथ्स की आपने कौन सी किताब पढ़ी थी? एसएम यूसुफ की पढ़ी थी? एसएम यूसुफ की अगर आपको याद हो तो वो उसके टाइटल पे इस तरह लिखा हुआ था. सो इट मीन्स कि ये इंटीग्रेबिलिटी नहीं है. Once again, at the cost of repetition, I'll say that when you solve the differential equation, solving a differential is nothing but the process of taking an antiderivative. So the solution is nothing but the integral of the solution, because you are taking the derivative, the integration, the antiderivative. So it is also, the solution curve is also called the integral curve and all that. So it's the whole process, but this is the integrability condition, but this is the criteria to define an equation, exact equation. Okay? एक तो ये चीज है. What is the other thing? So let's say, now how will you solve it? That is the whole idea. So curly m over curly y, and just have a look at this, that, okay, all right. So m is defined as curly f over curly x. So now if I want to find f, what will I do? And m is a function of xy. What would be here? Tell me. Function of y, good. So something, so this is something very different from integrating a function with single variable and a function which is basically f of fxy, g of y. So when you integrate in multivariable calculus, you do not get a constant of integration, you get functions of integration. Okay? That is the main difference. So the simplest example is that if I have df over dt is equal to 0, where something is just a function of one variable, your f is equal to constant. But let's say if you have f of xt and now you take this is equal to 0, now you solve it, it will not be a constant, but some function of x. So you deal with functions here, not constants. Okay, that's the basic thing that you must understand once you deal with multivariable calculus and of course the partial differential equation. So there is this constant. Now if I take the derivative of this with respect to y, what do I get? G dash of y. Okay. What is curly f over curly y? That is n. So n of xy is equal to curly over curly y mxy dx plus g dash of y, and my g dash of y is equal to n x of y minus curly over curly y mxy dx. And now if I integrate it with respect to y, so then I will have g of y is equal to my answer, and you find the whole thing. And similarly, if you don't begin with this and you begin with n is equal to curly f over curly y, then you will have the same thing, but you will have some h dash of x here, you will have m of xy here, and you will have curly over curly x n of xy dx here. So both methods will give you the same solution, right? Questions, please ask. Yeah. Cauchy Riemann, हाँ वो Riemann's equation जो वो complex के लिए, yeah. Analytic or not, yeah. वहाँ पे analyticity is important, yeah. ये function of real variables, this is not complex plane. हाँ, of course. The complex space is more general space because you are dealing with, you know. Same तो हैं भी और नहीं भी, because complex space is very different. वहाँ पे आपको जो domains simply connected हैं, किस तरह से connected हैं, वो सारी चीजें वहाँ matter करती हैं. यहाँ पे उस तरह से आपका ये simply connected है basically. But yeah, there is uncanny resemblance over here. But of course, it's in the real plane that we are talking about. ठीक है? How many of you were told this thing? The problem with our system is that somehow they start solving the problems and not tell you why this thing works. So you have to go through the theory. So for instance, I follow ZIL, whichever book I follow, whether this Riley and Hobson, they always give you theory first and then they say that, you know, that's how things work. So you have to read the book, learn the theory, and then start doing the stuff that you want to do. Okay, so there is something which is that is to be discussed over here along with this, is that sometimes the equation is not exact. So what do you do when you, so for instance in the variation of parameters, what do? You have a non-homogeneous equation, let's say, you multiply it with an integrating factor and it becomes, you can write it as an exact differential and you integrate. So let's say if you are given an equation in this form and it is not exact, then what can be done? Any idea? Gigi, please. जी जी बिल्कुल एग्जैक्टली सो वो आपके पास म्यू ऑफ एक्स वाई सम एम डी एक्स प्लस सम म्यू ऑफ एक्स वाई एन डी वाई इज इक्वल टू 0 राइट. सो इसके लिए जो है वो एक खास तो ओके क्या आपने एग्जैक्टनेस की क्या कंडीशन निकाली थी? कर लिया एम ओवर हाँ y इज इक्वल टू तो यहां पे क्या होगी फिर बताइए. फ्रॉम द सेम एनालॉजी आई वुड से म्यू ऑफ m y should be equal to right. Okay, now if I write it, I will write it as mu y m plus mu my is equal to mu of x n plus mu n of x. And I can write this as mu of y m minus mu of x n is equal to nx minus my. Well, I can do it the other way around as well, but okay, it's nothing, no worries. It's okay. All right. So what is this mu y? This is d mu over dy, and what is mu x? D mu over dx. Now tell me, is my problem solved here? Now what is the impediment in my way? Let me write this equation down here somewhere so that you can appreciate it. This is d mu over dy m minus d mu over dx is equal to nx minus my mu. G, and thank you. Thanks, G. What is the problem? Identify the problem here. You have not learned how to solve a PDE, and over here you have, mu with respect to x, mu with respect to y. So you will have to take either mu of x or mu of y. Okay? So if I, let's say d mu over dy equals to 0, now it's, straightforward matter. It becomes d mu over mu and something over there, and mu is equal to e raised to power something dx over here. Okay?
So we can also write one term in we can also write y in terms of x and mu, and the other way around too.
Mu can't be a function of both the variables here. If it is a function of both the variables and both the derivatives exist, you can't solve this equation. You just can't over here. Okay. Because first of all, it will not be an exact differential, that will be a partial differential. In principle, this should be partial mu and partial mu over partial x, right? So in one case, I will take mu of x equal to 0, and in another case, I will take y equal to 0, and then it's just the exponential stuff. So without doing that, I'm just going to write it down, and we will solve a problem which will be very instructive. So for both the cases, I will have these forms. So if I have mu of x, that will be e raised to power integral my minus nx over n dx, and my mu of y, I think it will be just the other way around. It should be, it will be nx minus my over m dy. So you multiply and you will make your equation exact. So first things first, you have been given xy dx plus 2x square plus 3y squared minus 20 dy is equal to 0. So first you check it for exactness. This is m. So curly m over curly y, what it is? Yeah. And 4x equation is not exact. Now you have to choose which one of these you need to multiply to make it exact. Okay? Because this is not an exact equation, you have to make it exact. So in order to do that, you have to multiply by an integrating factor, but you need to first find which one is the right way. So then do it. This is m and this is n. You try first try my minus, first try this one and tell me what you get. यही तो सारी बात है. Let me show you. चलें ये because how many of you have ever done it, by the way? Okay, good. So not many. Worth doing it. My minus nx. So what is my n? 2x square plus 3y squared minus 20. And what is my my minus nx? ठीक है? अब बताइए. ये तो तबाही फिर गई है. ठीक है ना? क्योंकि x and y's are not required. I need to have something which can be differentiated over x or y alone. I can't have a function which is dependent upon x and y. So now try the other way around. Go ahead. nx minus my over m try करें. Go ahead. Right? So that is a function of one variable. So that is how you decide which one to choose, because this is not the right way and this turns out to be. So one of these methods will work out in your problem. So that is how a non-exact equation can be made exact. These are the two recipes given to you. So one recipe will definitely work for one particular problem. Okay? Polynomial की बात नहीं है. You just can't have something. Integrating factor ऐसा नहीं हो सकता which is a function of two functions, of two variables, sorry. It has to be a function of one variable alone, because you are dealing with something which is a function of either x or y alone. Otherwise you can't do that. नहीं आएगा ना. ये तो नहीं. This is guaranteed that you can make it exact following one of the two recipes. Yeah, of course, tamam. If both things fail, then you can't make it exact, right? Yeah, true. But generally speaking, I don't know about the generality, by the way. At the moment, all I know that if equation is written like this, and if it is not exact, then you can make it exact. अब ये क्या हमेशा हम कर सकेंगे? Well, my educated guess would be no. Well, some method, yeah. Some method. Okay. So this is what it is, and now I need to go to a different type of substitution method. आपने पढ़ा है, right? So I'm going to talk about substitution method, but okay. So let me begin with I will go by the ordering of Riley and Hobson. All right, okay. This is what it is. So I begin with the homogeneous equation. So first you need to identify the form. If you are given something, dy by dx is equal to a of xy over b of xy which is in this form, y over x, okay? How to deal with it. But there is a restriction here that you can do this if and only if the degree of, whatever is given here and whatever is given here is the same. ये नहीं हो सकता कि आप, यानी वो उसने यहाँ पे लिखा है कि आप let's say a is equal to x square y minus xy square लेते हैं, तो b जो है should be x cube plus y cube. So you can see that this is 2 plus 1 3, this is 2 plus 1 3, and this is also 3. So if it is in that way written, then this method is going to work. Otherwise, you will not be able to apply this method. So you should also know the limitations of the application of a method. Okay? If that is so, then all that you need to do is you need to make this substitution, and once you make this, अच्छा अब देखिए आप, this is the sort of stuff that we were talking about earlier, that you have some x square plus y square over xy. This sort of thing you can't solve with the help of separable equation. Okay? You can see clearly over here. But the degree is same, so now this recipe works. And what it does for you, it will reduce this equation into a separable equation. These are the things that you should look at more than anything else. The rest is just the algebra. What you do, under what conditions you can do, and what is the essential idea. The essential idea is if the degree of the terms in the numerator and denominator are the same, if they are not written in the separable form, and if they are in the form y over x, then you can make this substitution and it will reduce this equation into a separable form, meaning it will be very easy to integrate. Okay? So let's do an example. I will not go till the very end, but I'll just show you how this works. So dy by dx is equal to y by x plus tangent y by x. Okay, let's try and do that now. As you can see, separable form नहीं है ये. Okay? Recipe आपको क्या बताई गई है? Y is equal to v of x. Now because you have done something, once I'll take the differential with respect to x and whatever, what will be the variable in which you will be writing this equation? What is the new variable over here? V. Good. So that is why it is called a transformation. You now go to a new variable, and once you write your equations in that variable, they will be in the separable form. And that is the power of this method. You know what I mean? So dy by dx will be equal to v plus x dv over dx. Once I plug it in here, I will have v plus x dv by dx is equal to v plus tangent v cancels out, x dv over dx is equal to tangent of v, and now this is in separable form. Lo and behold, as they say. That is what I promised. That is what you get. And once you find out the answer, you will just plug it back, v is equal to y over x in the original set of, because eventually the task before you is to find y, not v. So once you take the integration, you get the answer, you will eventually change it to y over x. So the solution that you get over here in this case is okay. So if I write that log of x plus c1, and this is equal to so if you take it here, this will become cotangent of v, and cotangent of v will be log of sine v. So eventually you can write this thing as, so if I do this, what will I get? Sine of v e raised to power log of x will be x cx, yeah, so c I can account for, okay, if you write cx, and v will be equal to sine inverse c of x, and this y is v, so y is equal to x sine inverse c of x. तो ये आपका उस वेरिएबल में दोबारा आप चलेंगे. Okay, all right. The next is the ये नॉन लीनियर इक्वेशन तो नहीं आपके पास उस तरह से आई अभी तक. यहाँ पे सिंगुलर, हाँ नॉन लीनियर है ये. It is non-linear. Yeah, it is non-linear. So you reduce this non-linear equation into a linear equation and you get the answer. But in this case, you don't get that. नहीं, two variable the issue नहीं है. Non-linearity does not depend on this. Non-linearity depends on this. So if you have this, it means it's a non-linear equation. So again, यहाँ पे भी you need to understand that this equation is essentially non-linear. By applying this transformation, you have reduced a non-linear problem into a linear problem. But that is not what defines a non-linear problem that way. नहीं वो आपके पास dy by dx is equal to 1 over x है, आपके पास y is equal to log of x है, तो ये कोई नॉन लीनियर प्रॉब्लम तो नहीं है ना. हाँ हाँ वो उस तरह से या so it is a non-linear equation, but you can now write it in separable form. So just like when I said dy is equal to y square minus 4 over dx, so it's a non-linear problem, but because it's a separable you can do that. Over here you can also do that. Yeah. Yeah, exactly. But अभी आएंगी, जरूरी नहीं है कि अभी यहाँ ना नजर आए. तो मैंने कहा हर बार आपको not necessarily that you can see it very clearly, but I'll show you in a moment कि कैसे, how do they pop up. There's another equation. How many of you have heard about isobaric equation? Isobaric वो नहीं है जो thermodynamics वाला. This is isobaric differential equation. What trivial solution? That is called the trivial solution. Yeah, good. Thank you very much for reminding me. Y is equal to 0 is the trivial solution of all these differential equations, right? Trivial solution is like normalcy is a paved path, but no flowers grow on it. So trivial solution is that kind of a solution. Oh, the time is over. Okay, so we'll pick up the thread from here on Tuesday. Questions, please ask. चाहे कब तो हम डिजर्व करते हैं वो आप पिला ही देंगे हमें without sugar. Yeah. Questions? So this is amazing. You have encountered nonlinear equations. You have managed to solve them using the separable equation. You have just encountered something, again a nonlinear problem. You have used a transformation and you have managed to reduce that nonlinear equation into a non-separable equation into a separable equation. तो आप जब आगे जाके फिजिक्स पढ़ेंगे और बहुत जो है बुलंद बातें सुनेंगे, over there also there are transformations which make the life very simple. For instance, don't go far away. For a linear problem, your Fourier transformation or a Laplace transformation converts an differential equation into an algebraic equation. So these are all the kind of facilitations that you create for yourself. So these are amazing transformations, but of course you need to know how, under what conditions they work. For instance, Fourier transformation and the Laplace the Fourier transform and the Laplace transform, they are both integral transforms. So meaning that they are linear transforms. In order to solve a nonlinear equation, you can't apply these transforms. So you must know the limitations also. Then you have to come up with different methods. So for instance, one method is the what we call the traveling wave method, where you convert a nonlinear PDE into a nonlinear ODE. This is what we do in nonlinear PDEs. So you create some kind of ease for yourself. We will talk more about it. Transformations are fascinating because they create immense ease for ourselves. No. Y over x